Hello everybody, and welcome to a video on an introduction to loans, amortization tables. The reason this video exists is that your book does not spend very much time on loans. Your book only dedicates a page or two to them. And loans are incredibly important though. If you're going to have a unit on financial mathematics, that unit will be incomplete without some non-trivial discussions of loans and how they work. So, as I said in class, I'm posting this video so that you can reference it in lieu of your textbook, which has very little information on loans. The goal of this section is to understand how loans work. To understand how a loan works, you must be able to read and build an amortization table. So amortization tables are at the heart of what a loan is doing and how it works. So let me just start by showing you an example. What is such a thing? So here's a loan setup. This guy named Jack takes out a 5-year car loan of $12,000 and the APR is 3.5%. He's going to pay the loan back in monthly payments, as almost all loans are done. Almost all loans work on monthly payments, especially car loans or house loans, things like this, student loans. So I would just tell you that his minimum monthly payment is $218.30. So next time we're going to get these numbers, this payment number, from an online calculator. But for the sake of this video, it doesn't matter where it comes from, just accept that this is what the payment is. So for 5 years, this Jack guy is going to write a check to the bank, or whoever controls his loan, for $218.30. At the end of the 5 years, his $12,000 loan will be paid off as a result of these monthly payments of this size. Okay, so an amortization table looks like this. It has, for us, 5 columns. A payment column, which just keeps track of which payment you are on. So here's your first payment, your second payment, your third payment, and so on. Since this guy is making monthly payments for 5 years, his amortization table will have 60 lines in it, each line for the 60 payments he will make. And so a 60-line table will not fit on the slide, which is why I cut it off at 3 lines. But just it's worth noting this table continues for a long time. The second column, you will just put in there how much you're paying each month. So in Jack's case, if he just decides to pay $218.30, that's what we'll go with here. So let me just put that there. Okay, so now here is the most important thing about how loans work. This first payment, okay, Jack is going to make this payment a month after he takes out this loan. So the bank has given him $12,000 to buy this car. A month later, Jack has to start paying it back. He will write a check for this amount. Some of that money will just be pocketed by the bank as interest. Okay, so the bank is not loaning him this money as a charitable action or something. They are going to keep some money as a fee for allowing Jack to use that money. So this $218.30 will be split into 2 pieces. One piece will be interest that is just pocketed by the bank. The other piece, which is called the portion to principal, that piece of the check goes towards paying down the loan. This final column, remaining balance, that just means how much money you still owe on the loan after this payment is made. Okay, so let's do it. Let's actually fill out this table. So Jack has gone to the bank. He's made a payment of $218.30. He's written a check. What does the bank do with that first payment? Well, first, they calculate how much of that payment they get to keep as interest. And they use the simple interest formula, PRT. And what the bank will do is, P now is the principal. That was $12,000. That's what Jack borrowed. The interest rate is 3.5%. You have to write it as a decimal, so 0.035. And then the amount of time that has elapsed in years is 1/12. Okay, there are 12 months in a year. A single one of those 12 months has elapsed. So 1/12 of a year is how much time has gone by when he makes this payment. So the amount of interest they will keep is PRT, $35. So that's what goes right there. Jack gives them this check for $218.30. The bank pockets $35 of that. Okay, so the question now is, well, how much of that money is not interest? How much of it goes towards actually paying down the loan? The portion of principal, just take the check amount, that 218 bucks, take out the fee the bank just pocketed, and the rest of that goes towards paying down the loan. So you take your $218.30, take out the interest amount, and what's left over is the portion to principal. It goes right there. Okay, finally, the question is, well, after all of this has taken place, you write a check, the bank keeps some of it, and they use the rest of it to pay down the loan. How much money do you still owe on your loan? And the answer is the amount you currently owe minus the amount that the bank just put towards principal. And so right now, because you haven't made any prior payments, you owe $12,000. This is your first payment, so you still owe them $12,000. They're going to take that portion of principal and apply it towards that $12,000 number for a result of $11,816.70. So that's what goes right there. So we have now filled in the first line of this table. This first line shows you exactly what happens to this first check you write on your way to paying down the loan. So again, just to recap, this check amount is split into two pieces, an interest piece and a portion to principal piece, which is actually used towards reducing the amount you owe. The bank calculates the interest based on the PRT formula. Whatever is left over from that check goes towards principal, so you take this chunk out of however much you owe. Once you've completed the first line, you just move on to the second line. And again, now we're at the end of month 2, and Jack has to write them another check. He wrote them this first check at the end of month 1. Here's his second check at the end of month 2. He has to keep doing this for 5 years, right? It's a 5-year loan. So the question is, okay, of this check, how much is interest? And again, to calculate that, the bank must use this formula, PRT. It's just that now the principal is actually different because you do not owe them $12,000 anymore. They can't charge you interest on $12,000 in this line of the table, the second line, because you don't owe that anymore. They would be cheating you if they did that. So what they will do is they will take the amount that you currently owe, that's the principal amount now, times the APR, times the new time window. Okay, so you already were charged for the first month of interest, so this 1/12 is just the next month of time. So here's the amount you owe, times the APR, times this new chunk of time from payment 1 to payment 2, and now you get $34.47, and that goes right there. So notice they're keeping slightly less of the check as a fee. So the portion of principal now is just take what's left of this check you wrote, take out the interest amount, and you get 183.83. Put that in portion to principal. And then at the end of month 1, you owed them this much, $11,816.70. At the end of month 2, you just take this portion of principal and take it out of this chunk of money, like so. So again, when you write the second check, you don't owe them $12,000 anymore. You owe the bank $11,816.70. So when you take the amount of your check that actually goes towards paying down your loan, you apply that money to your remaining balance from the previous month. And you get that 11,632.87 number. And you just keep going like this. If you can fill in the first 2 lines of a table, you could in principle fill out the rest of the table. Now, of course, this is a 60-line table if you wanted to build the entire thing. You guys will, of course, not be doing that. It's just a waste of time to make you fill out more than 2 or 3 lines of a table. Because again, if you can fill out the first 2 or 3 lines, then you know what's happening. You could, in principle, fill in the rest. So let's fill in the third line here. So finally, at the end of month 3, Jack makes it again the same check amount, payment amount of $218.30. If you apply the I equals PRT formula to this 11,632 number, you get $33.93. And then what's left over after that $33.93 from this check is $184.37. You take this $184.37, take it out of what you owed at the end of the previous month. out of this number right here, the 11632.87, and now you get 11448.49. Okay, so all that to say, you just keep doing exactly what we just did, and you could fill out the rest of this table if you felt like it. Okay, so let me just give you another scenario. The same setup, 5-year auto loan, $12,000 loan amount, APR of 3.5%. The minimum monthly payment is $218.30. But whenever you take out a loan, that payment amount there, that $218, it's a minimum, but you can pay more than that if you want to. If you pay more than that every month, the result will be that your loan ends early, so you actually won't have to pay for 5 years. So let's just see a scenario like that. This Jack guy is going to pay off the loan early, so he's going to pay $250 for his first payment. So instead of a check for $218.30, his first check is for $250. After this first payment, he goes over his budget and decides he can actually afford $275 a month. So from then on, he'll pay $275 a month, not $218.30. So let's build an amortization table for this scenario. So recall, in the original scenario, he was just making the monthly minimum. But now in this new scenario in red, these are his check amounts, his payment amounts. At the end of month 1, he writes a check for more than $218.30. At the end of months 2 and 3 and in perpetuity, he writes a check for more than $218.30. And the first month is $250, and the second and third months is $275. Okay, but the process of building the table is the same. So now the interest at the end of the first month on payment 1 is still PRT, where P is the amount that you owe. At the end of the first month, you owe $12,000 because you haven't made any prior payments. The APR is 3.5%, and the time is a 12th. So you get $35. So that hasn't changed. But now notice what does change. The portion to principal, the way you calculate that is take the interest out of this check you just wrote. So the bank gets to pocket $35. All of the rest of that check amount goes towards paying down the loan. And so now you have $250 as your payment amount, and you take $35 out of that, and you get $215 as your portion to principal. The remaining balance, just like before, is the amount you currently owe minus the portion to principal, which in this case is $11,785 when you take that $215 number out of the $12,000. So just to compare this to the prior scenario, the interest amount after the first month is the same, but notice the portion to principal is higher, which is as it should be because you gave them a bigger check. So the additional money you're giving them is going towards paying down the loan. As a result, your remaining balance after the first month is smaller. You owe them less after the first month because you paid them more than the monthly minimum than you did in the previous scenario. So if you keep doing this, you're still going to keep using PRT. So this right here, this is PRT, where I'm using $11,785 as my P because that's how much I owe them, and the rate is still 3.5%, time is still a 12th, and then I take this money out of here, this 34.37, I take it out of 275 to get this 240 number right here, and then with this 240 number, what do you do to it? You apply it to how much you currently owe, and at the end of the first month, you owe them $11,785, and now 240.53 is being applied to that, and you get 11,554.47. So you just keep doing the same thing. Notice, since you are paying more, the amount you owe is less. Right? 11,785 is less than 11,816. 11,544 is less than 11,632, etc. Notice the interest amounts in red are also less. Why is that? Well, because every time you're using the PRT formula, the P number is lower because you owe less. So if you decide to pay more than the monthly minimum, your interest numbers will fall faster because you owe less and less than if you were just making the monthly minimum. Okay, so in conclusion, what should you take away from this section? Given a payment amount, which again, This 218, where is it? 218 number I just handed to you. So for now, just take it as a given. We will talk next time about where this number comes from. So given that payment amount and an interest rate and a time period like months when you're going to make your payments and a life of the loan, so just given everything we had, you should be able to fill in by hand without the assistance of an online calculator, which we will use next time. Okay, so I'm just saying that the tool I will show you next time, you can't apply to a question like this. So given all the parameters of a loan, you should be able to fill in the first 2 or 3 lines of an amortization table just like we did in these examples. You should be able to do this PRT thing to get the interest amount, portion of principal, and remaining balance, and then just keep the process rolling. Now notice it says for the first 2 or 3 lines. Again, that is because I'm not going to make you do this for the entire life of a loan. It would take too long. Okay, the second goal is you should be able to articulate the following facts about loans. All of these facts assume you're making the monthly minimum. Okay, so it's worth throwing out. Over the life of the loan, the amount of interest that the bank keeps from each check goes down. As we saw, right, 35, 34.47, 33.93, the amount of interest the bank keeps decreases over time. And the reason is because when you're using this PRT formula, P represents the amount you currently owe. So if the amount you currently owe is getting smaller, the resulting I number here will also be smaller. So you should be able to articulate that. You should be able to tell me that the amount of interest goes down. And you should be able to tell me why. Because the amount that you owe goes down. Here's something else you should be able to articulate. Over the life of the loan, the amount of each payment that goes towards principal goes up, not down. And the reason is because if the interest is going down, the amount that's left over to go towards your loan is going up. There's just more there. So more and more of your check that you're making every month is going towards paying down the loan and not going towards interest. So as we've seen in both the red and black examples here, as interest goes down, the portion to principal goes up. And finally, over the life of the loan, the remaining balance goes down. Okay, so what's happening here? The amount that you owe to the bank should be going down over time as you make your payments. If the amount you owed them were going up, then you are getting really screwed by the terms of this loan. If the amount that you owe is going up, then you might never pay off the loan in your lifetime. Okay, the amount of the remaining balance has to go down. Okay, the last thing that's worth mentioning here is the remaining balance falls more quickly at the end of the loan than at the beginning. Okay, so notice here, at the beginning of this loan, the amount of interest is kind of high, so the $12,000 number isn't falling very fast. Towards the end of a loan, the amount of money that goes towards principal is going to be very high, and so your remaining balance will fall much more quickly. Okay, so those are the 2 goals of this section. You should be able to do these things on an exam.